All right, welcome to Unit 2, Lesson 6. This is on long run costs. This will finish up this entire unit of material. And we're doing one more thing with our cost curves. We're seeing what happens when we move out of this situation of the short run, where you've got fixed costs and variable costs, and into the long run. And the definition of the long run in these analyses are that in the long run, that's the period in which all costs are variable. A little bit different than the definition of the long run in macroeconomics. If you're doing that, or if you did it last semester, that is even a more nebulous definition. But in microeconomics, the long run is that period where your fixed cost contracts are up, and you can choose to add on. For instance, you want to add another factory you have, or get rid of one of the factories that you have. In the long run, you have the ability to do that. And so you have no fixed costs over the long run. All costs are variable. To tell the story of this, we'll go right back to our Lynx factory, and then we'll also use what the book has, which is the boots production. So let's talk about the Lynx factory for a minute before we get into the numbers. Say that for each of those groups, you tended to produce somewhere between 10 to 20 units of Lynx during that experiment, depending on how many workers you had. But you probably couldn't have got much beyond 20 or 30. Maybe if you practiced and you got a lot better at it or whatever. But no matter how many workers we added, how much paper we added, our fixed costs were keeping us from producing very much. Say that we had a goal as a firm. The market demanded something more like 100 or 200 Lynx be produced. In the short run, we would be unable to do that. If I said you need to figure out how to produce 100 Lynx, you say impossible, because we've only got one small desk, we've only got one pair of scissors, we've only got one roll of tape, and you can add all the workers you want, but we're not going to be able to get to that level. Well, over the long run, we could have bought another pair of scissors, another roll of tape, another desk, and we could have gotten our factory big enough and our machinery big enough that we could get to whatever level we want. So that's the sense in which all costs are variable. At that point, at the point at which we can buy more stuff, then it depends. Just depends on how much we want to produce as to what the size of our factory is, and therefore we have no fixed costs anymore. They're all variable costs in the long run. So whether we bought one table or more scissors or more tape would depend on how much we wanted to produce, and it doesn't take a lot to understand that if we wanted to produce a larger amount of Lynx, like 100 or 200, then it would probably be the most cost-effective thing for us to do to purchase more capital materials, more of those things that we called fixed costs before. Whereas if we were only shooting to produce 10, 15 units, if that was our goal, then there's no need to produce or to buy additional tape and scissors and all that. It wouldn't be cost effective for us to do so. So that's the basic concept behind what we're doing in this lesson, is that over the long run, you can look at changing your fixed costs to meet your level of output, the level of output you'd like to produce. And then we want to see what patterns end up happening, usually for a firm as a result of those decisions. So this first table and graph we have looks a little bit complicated. What we have is, looking at on the graph, two different average total cost curves. These two average total cost curves go along with two different options for levels of fixed cost, and probably an even more helpful way of thinking about this is number of boot making machines. Let's say that this is if the company decides to buy 2 boot making machines, then it faces this high fixed cost, $216. Say that's rent on the boot making machines. But if it just chooses to have 1 boot making machine, then it'll face this low fixed cost of $108. So if we just plug that new fixed cost, those two different fixed costs, in with our quantities of output that we had in the previous lessons, then we get different levels of fixed cost. We also get different levels of total cost. So here's what's going on here. This part's probably the most complicated part here. Notice that our variable cost changes depending on what our fixed cost is, depending on whether we have 1 machine or 2 machines. Think about that this way. With 1 machine, workers can produce a certain amount. with 2 machines, they can probably produce more per worker. So what happens here is that our variable cost is lower with a high fixed cost than it is with a low fixed cost. Our variable cost is higher with a low fixed cost and lower with a high fixed cost. Okay, let's take this into real life. Consider with our factory in class, if you're trying to produce a small amount and you just had the one tape, scissors, and table, then the additional cost, each worker is going to produce probably a little bit less than they would with 2 scissors, 2 tape, and 2 desks. And that's true whether you're producing 1 pair of boots or whether you're producing 10 pairs of boots. Now, it doesn't necessarily mean we should buy two everything, or in this example, buy 2 boot making machines. It depends on what output we're going to produce. So think about it this way. If we're going to produce 1 pair of boots, that's all we're going to do, then let's just look at the average total cost of producing 1 pair of boots. The total cost of producing 1 pair of boots with 1 machine is $12 variable cost plus fixed cost $108 equals $120. 120 divided by 1 gives us the average total cost of $120. So it costs us $120 per pair of boots to produce a pair of boots, 1 pair of boots, if we have 1 boot making machine. What if we wanted to see what happened if we bought a second boot making machine, still only producing 1 pair of boots? Now our variable cost drops to 6, but now we add this much larger fixed cost, get a higher total cost of $222, which is also our average total cost. So if we're just going to produce 1 boot, then our choice is between with 1 machine, then our average total cost is $120, and with 2 machines, then our average total cost is $222. So we should choose to get just 1 machine if we're just going to produce 1 boot. So if we compare down this column and this column, we can see whether 1 machine is better or 2 machines are better, depending on how many boots we want to produce. So that we already said with 1, now with 2, we're comparing 78 and 120, so again, it's 1 machine. With 3, 72 and 90, again, 1 machine. With 4, it's the same. 1 machine's better. And with 5, now it flips. Once you produce the 5th boot, think about producing the 5th boot, now you have a lower average total cost with 2 machines because of the efficiency you gain from that than you do with 1 machine. That's going to keep being true now all the way down. Think back about why average total cost is U-shaped, what we did in that last lesson. We said that average total cost is U-shaped because you start out with a spreading out your fixed cost, and then eventually diminishing returns kicks in. That's what's happening in both of these examples too. It's just at lower levels of fixed costs, you're better off with producing less with lower levels of fixed costs because that spreading effect happens faster. It takes longer to effectively spread out the cost of producing your second machine. It doesn't really happen until you get to the 5th boot and beyond. You're better off with 1 machine with if you're producing lower levels of output, 1 through 4. Okay, we can also see that graphically if we graph both of these average total cost curves, this one and this one. Sorry, it's getting pretty messy. This one we call ATC1, and here it is, and this one called it the low fixed cost, again the 1 machine graph of average total cost. And over here we have the other column, the 2 machines average total cost. So again, we can take this kind of one at a time. For producing 1 unit of boots, we're going to want to pick the lower average total cost, so we're going to want to pick this one. And if we're producing 2 units, again, this one's lower. Once again, we cross past 4. If we go to 5, now ATC2 is lower than ATC1. It stays that way. So the graph shows this in the book as a dotted line, saying here, to the left of here is where 1 machine is better, low fixed cost, and to the right is where 2 machines are better, higher fixed cost. So in general, as you increase output, it usually becomes advantageous to add on more fixed inputs short-run fixed inputs, basically to buy more capital equipment in order to minimize the costs of production. Hopefully that makes some intuitive sense, and you'll do some problems in the book where you have to work with the numbers and kind of show that in the same way that we did in this example here, and then also graph it. So that's just two options. In real life, this firm would have the ability, the opportunity to buy as many machines as theoretically it wanted. You could buy 3, 4, 5 machines, whatever. And so what we'd end up having is a whole bunch of ATC curves leading to eventually something that looks kind of like this. And this one, we can work with this one, but I think let me draw one from scratch I think is even more helpful. Let's think of it this way. Let's think of a firm. Here's quantity of output that faces the choice between 1, 2, 3, 4, or 5 machines. And what's going to happen is that their average total cost might look something like this. Here's the average total cost of one machine. Here's the average total cost of 2 machines. Here's the average total cost of 3 machines. 4 machines, and 5 machines. It looks a little bit sloppy right now, but what we're going to do, well, I think you'll get. Watch this. If we go all the way from 0 to here, let's call this Q1, we're best off with 1 machine. That's the lowest average total cost we can get. From here to here, Q2, we're best off with 2 machines. See, I'm tracing there the ATC2 as the lowest option there. From there to Q3, 3 machines. From there to Q4, 4 machines. And from Q4 on, we're best off with 5 machines. So if those are our options, this red line here now becomes what we call the long run average total cost curve. Because that's the range of options for a firm that is considering any of these quantities. So that basically just comes from the different average total costs of different levels of fixed costs. That's the same thing this graph over here shows. I think it's just slightly less clear when you look at it on here. So here we've got the this ATC3 represents the best average total cost if you're producing 3 units of output. This one that they call ATC6 represents the best average total cost if they're producing 6 units of output. And this, ATC9, represents the best average total cost if they're producing 9 units of output. And then what they've done is drawn a nice kind of smooth connecting curve to all 3 of those points, A, C, and X, and call that the long run average total cost curve. So that's basically like what we did over here. The way that you'll often see the long run average total cost curve is as just a single smooth line, looking a lot of times kind of like this. Again, quantity of output on the x-axis and cost on the y-axis. Notice what was happening here is that as we, up on the graph on the upper right now, as we increased output and bought more and more machines, our average total cost generally fell, even over the long run, until we got to that 5th machine. This is probably a pretty familiar concept. It makes a lot of kind of obvious sense. It's called economies of scale. In this region here, and basically all along the upper right in this region here, then this firm is, we'd say, experiencing economies of scale. Economies of scale simply means as you increase output, then your long-run average total cost decreases. In other words, as you get bigger, you get more efficient at producing the stuff you're producing. So we've all experienced the thought of, okay, so how, these big, huge companies, firms, your Walmarts or your, big chain retailers or your big chain restaurants, they're probably able to produce stuff more cheaply because they're so big that they take advantage of the efficiencies that they can gain from that. Well, that's another idea about, that's another way of talking about the economies of scale that a firm will see. As it gets bigger, it can find ways to be more efficient. It's shipping, procedures, distribution, whatever. So that'll often happen. And then there will also often be a time period or a level, some levels of output where basically it's flat. The long-run average control cost is flat. It costs about the same to produce additional units of output in terms of the average cost. And we call that constant returns to scale. The scale refers to the size of the output you're producing, the amount of output you're producing. And then eventually for many firms, this part seems a little counterintuitive, but you do see a time where when you get big enough, so big that, Walmart's another good example where this has actually happened. What's happened is that, Walmart used to be a lot more profitable than it was. A lot of it was because, during their growth period, they were opening up new stores, but another big part of it was because that they were not quite yet big enough that they faced a lot of coordination problems. So this is an example of this concept called diseconomies of scale, where you get so big that you become a little bit less efficient because you've got to coordinate such a vast empire of production for whatever, you're spread out too far, or there's just so much to deal with, or you're having a hard time managing it, or whatever. Diseconomies of scale could happen when you get so big that you end up increasing. It's not exactly the same as diminishing returns because we're not talking about any fixed inputs here. It's just there's a point at which you can only get so big. It's pretty similar to diminishing returns, just we use a different term for it when we're talking about the long run. That's diseconomies of scale. Okay, in class we'll do several book problems where you do some of these calculations. You'll actually develop one of these types of graphs, or a graph that's kind of similar to the one that I did here, and we'll see you in class.